Hello everyone, and welcome to the 3D Buzz OpenGL VTM series. My name is Jason Busby.
And I'm Joel Van Enwyk.
And over the next couple of VTMs, we are going to walk you guys deep into the world of OpenGL and how to go about creating your own graphical applications.
Oh yeah.
Yeah, this is going to be a lot of fun. This is where things are going to become a bit more complex from some of our past C++ VTMs.
Right.
So one thing that I've got to say right up front is please make sure you have a decent understanding of C++ before trying to go through this VTM.
Right.
Because we are, of course, going to assume that you do have that understanding, because we don't want to, step over to the side and start talking about pointers and variables and memory addresses and stuff like that.
Right, we've already taught that.
All that's out of the way. So when we pull up code, we expect you to be able to identify with the code
what a function is.
Exactly. But, of course, we're going to walk you through what's taking place.
Right. Anything new regarding OpenGL, we're going to hold your hand through the entire thing and make sure it's a really nice transition into the world of OpenGL.
Absolutely. So this is going to be a really fun VTM. What are we going to be covering in it? Well, first, we're going to begin with this introduction video. And this introduction video is going to go a little bit further than our normal introduction videos. Normally with the introduction, we say who we are, and we just say what we're going to cover, and say let's get started, and then begins the next video. But in this case, we're going to probably end up with a 25 to 40-minute video because we're going to talk about OpenGL.
Right.
What is it? What is it made up of?
Because that's the biggest challenge, actually. A lot of people will go, well, what is OpenGL? And they're completely confused by that.
Exactly.
Once you understand what it is, the entire whole big chunk that's called OpenGL becomes a lot easier to understand.
For sure. As a matter of fact, by the end of this video here, we're going to pull up some code that does a very simple, it handles the creation of a very simple OpenGL style application.
Right.
And we're going to talk about it. We're going to walk through the code so that by the end of this video here, you guys have seen an application implement OpenGL calls.
Right.
Okay. So what else are we going to cover in the very first VTM for OpenGL? Well, graphics architecture. Very, very important, wouldn't you say, Joel?
Right.
We're going to talk about transformations.
How to do transformations.
Projections. We're going to talk about the rendering pipeline in detail.
So that we know exactly what's going on behind the scenes. Even though you often don't need to do it manually, you need to know what happens behind the scenes so you can write your code accordingly.
Exactly. Well, to be honest with you, a lot of people aren't very familiar with all this low-level stuff, if you will. What's going on behind the curtain.
Exactly.
I mean, it's very easy to just get in there and start utilizing the function call.
Right, and just kind of blithely typing out code without really knowing what's going on.
Precisely. Having a true understanding of what's happening under the hood.
It's important.
It really is. It'll make you a better programmer. Okay, so from there we're going to be talking about how to interface with OpenGL. Obviously, OpenGL is nothing more than just a programming interface.
Right, a graphics library.
It's a graphics library, that's right, with some 120-odd commands that we can utilize for creating our objects, lights, materials, etc. But that's all fine and dandy, but we need some sort of vehicle to house it all, if you will.
Right.
And so we've got to create a window. Well, we're going to look at a few different window interfaces. We're going to look at Glut. We're going to look at SDL. We're going to look at WX widgets because we've been following WX widgets now since the C++ VTM number 4.
Yeah, that's right.
And we're going to take a look at the Windows API as well.
Right.
So we're going to try to introduce you to multiple ways of facilitating an application that utilizes OpenGL.
Right.
Okay. From there, a little bit of linear algebra, kind of a review, if you will.
Right. For some people, maybe even the first introduction to it.
That's very true. But we need to talk about matrices.
Vector operations. And all sorts of interesting things that you need to understand thoroughly before you can really use OpenGL.
Cross product.
Oh, yeah.
What does all this mean?
Yeah, it makes some people's head hurt.
Mine's already hurting. But we're going to talk about all of this, and we're going to make it nice and simple. And fun, yes.
Because it can be fun.
It can be. Yeah, okay. So anyways, after we get done talking about linear algebra, we're going to move into the world of texture mapping. Because obviously when you're creating graphical applications, texture mapping is extremely important.
Right, and materials, how to change their diffuse attributes, their specularity, and all that
let's not forget UVs.
Yep.
That's extremely important. As a matter of fact, by the time you guys get done, when we get done with this particular video with texture mapping, you guys are going to have a whole new understanding of UVs.
Right, not just a high-level view that you may have got from using 3D applications in the past.
That's right. Let's just slap a planar projection on it.
Right.
Woo!
Yeah, exactly.
This is a different world, guys. All right, from there, what we're going to do is take a look at lighting. Yeah, this is where things are going to get very interesting because we need to have an understanding of what is available to us inside of OpenGL in regards to lighting.
And what limitations we have, too. Because there's a lot of limitations when using a real-time thing like OpenGL. But once you understand those limitations, there are many ways to work around it, and it's just fun.
Right. Well, we'll talk about light types, of course, the point light, the directional light, spotlight. We're also going to talk about lighting models.
Right.
Primary focus or use will be with the Phong.
Right.
But we will talk
is what's used internally.
That's right. But we will be talking about blend and fog as well.
Right.
So let's see. What else? We've got display lists. Ooh,
yes.
Very important if you're concerned with speed.
Oh, yeah. A lot of times if you want to render your scene really quickly and it's the same object that you need to render over and over again, display lists is a way to throw it into OpenGL's internal memory so it has quick access to it.
That's right.
And we'll be discussing all of that in great depth.
We're also going to show you guys how to go about creating and using text, which is very important.
Yes, it is very important.
If you were to construct a game and you need text up there for the score and
or for debug
stuff,
information.
Exactly. You need to know how to go about creating it. And then a couple of interesting things as we kind of wrap up the introduction VTM. We're going to show you guys how to create an OBJ loader so that you can take your models out of Maya or 3ds Max or other applications and bring them into your own application.
Right.
So we will walk you guys through every step required to do the OBJ loader and, of course, how to have an application that's going to show you your model that you've brought in. And we're just talking about geometry, of course.
Yeah, because, I mean, can you imagine modeling an entire character inside of code? No.
That would be funny. No, you don't do that.
No.
And in the second VTM, when we get into intermediate OpenGL techniques, by the end, we'll be exploring how to go about creating an FBX importer.
Right.
And this is when we'll move into the world of pulling in not only geometry, but bone and skin information, animation, materials,
anything
lighting.
regarding an entire scene can just be brought in, an entire virtual world.
Exactly. Things you're not going to be bringing in with an OBJ loader because some of that stuff's not objects. But anyways,
that's right.
You guys get the idea. And then to wrap up the introduction to OpenGL VTM, we're going to walk through the creation of a complete particle system.
Yep.
So we're going to have a particle engine in the application to allow us to get into that engine and create some really interesting effects.
Oh, yeah.
But you guys are going to see every bit of code that's used to produce this. And at that point, then if you wanted to start creating your own game or something like that.
Your own demos if you wanted to.
Precisely. You can, apply these techniques in your own game or in your own application. So really neat stuff. Well, I guess the first place we need to start is exactly what is OpenGL.
Right.
And it's really nothing more than an application programmer's interface.
An API.
An API. It's a library of function calls that facilitates graphical type stuff.
Right, exactly. I mean, some people get really scared when you say OpenGL, and it's really just, like we said before, 120 odd commands that you can call that give you access into the hardware so that you can quickly display 3D objects without having to do low-level programming.
That's the key right here.
Yeah.
Is without any of these graphic APIs. I mean, and you guys can see we've got several of them listed down here: Figs, DirectX, VRML, and Java 3D.
Yeah.
And some are cross-platform, while others are not.
Yep.
It is. It's very important when you start creating a graphical application that you use some sort of programming interface that's going to handle all of your low-level graphics stuff.
I mean, you could write everything from scratch, and it is kind of interesting to do, but at the same time, if you want hardware acceleration...
Yeah, I was about to say, you're going to run into a very interesting problem because you're going to be writing for one particular video card.
Right.
If you're doing low-level stuff. In our case, OpenGL and these other popular APIs as well, we've got drivers for video cards nowadays that have been written to support, OpenGL, DirectX, etc.
Exactly.
So it's already hardware accelerated, which is awesome. So we can basically handle drawing routines with very little code.
Yep.
And then let the library worry about all the complex stuff that's taking place.
Which makes it work on all of the computers.
Which is awesome. Well,
it is.
For most of these.
For most of them.
Right. Some of them are, DirectX.
Right.
We're not going to run that on every platform in the world, but you get the idea. But yeah, that's a really big thing, Joel, that you just said. Cross-platform applications.
Right.
That's huge.
That is very huge. Like with OpenGL, you're given the opportunity to program for multiple platforms. And all you need to do is go into, say, Linux, recompile your code if you're using the right window interface like Glut or something.
And if you follow a few simple rules.
Yeah, there are some rules to follow. But once you follow those, I mean, it'll directly work when you go into another app.
Which is really cool.
It's very awesome because that opens up a whole new world. You have different audiences that you can target, and it's just awesome.
Right. Now, we do have added into the slide here that as a general rule, a 3D API needs to be able to specify. You need to be able to specify objects.
Right.
We need a virtual viewer that
Right.
allows us to view into our world in which we construct things.
Like a camera.
Yeah, light sources.
Yep. So you can light up your scene.
Exactly. And, of course, material properties.
Mm-hmm.
We've got a little diagram right here that's just showing you kind of, I guess you could say, the pipeline for the whole thing.
Right.
It's we start out by
pipeline.
a very simplified. We start out with an OpenGL application that we write.
Which is what you write.
That's right. And then, of course, we've got information that is being passed into the OpenGL library, and the library is handling all this low-level stuff for you, and then communicating over here with your video hardware, which, of course, that gets piped out to your monitor so that the user in the end sees the graphics that, well, your application said to create and show.
Yep.
That's right. So, Joel, is there anything else you want to add to this?
No, I think that's it.
It's really not that bad, guys. Like I said in the last slide, it's like about 120 commands that we're dealing with.
As new specifications come out, more gets added.
Absolutely, but that's not that bad.
No, it's not that bad at all.
So once you start getting, and there's not a whole lot that you need to be very familiar with to start becoming dangerous with OpenGL.
Precisely.
It's very few. You don't need to know all 120 commands to be effective.
That's right.
Okay.
And you just need to look in the documentation if you don't know something.
That's right. It's very simple stuff. All right, so comparing rendering techniques.
Right.
Obviously, there's multiple ways to go about rendering something out to somebody's monitor.
That's right. I mean, if you're using, say, Maya or some other 3D application, you may be used to things like ray tracing, scanline renderers, or all these different terms that people throw around.
Sure.
Those are all non-real-time applications.
And real time is very important to us.
It is very important. I mean, if you're going to do a game, do you want them to be running at 1 frame a second? I don't think so.
I've done it before, though. No fun.
So, yeah, I mean, but if we're using real-time rendering like OpenGL or DirectX, there are limitations to making it real-time. I mean, if ray tracing was slow and you could have real-time rendering that was just as good looking, something's not right there.
Or nearly just as good looking.
Yeah. So there are limitations that we have here. I mean,
well, while we do have no shadows, no reflections, there are workarounds, though.
There are workarounds. We can still use things like we'll talk about in a minute, like stencil buffers, that allow us to be able to create shadows, to create reflections.
That's right.
And there are per vertex lighting, which is a approximation of real-world lighting, because it's not per pixel.
Exactly.
But at the same time, there are now with per pixel shaders, we can do that now.
That's right.
So there are ways to get around all of these problems. Now, like with ray tracing, you automatically get shadows, reflections, and all that good stuff.
But the complexity just goes through the roof as we're now firing out a ray through the camera, collecting all of this.
Every pixel.
Yeah, exactly. All this information for each pixel. That's quite CPU intensive.
Yep.
So it's not just a matter of the fact that we have a super fast graphics card.
That's right.
Now we better have one hell of a CPU as well.
Oh, yeah.
And then, of course, radiosity. It's something that's it's kind of trickling off.
Yep.
You're not hearing it near as much as you did about 4 years ago or so.
But the techniques that are used in radiosity are still here today.
They are still here today. It's really just an approximation of reality with lighting, if you will.
Especially the soft shadow thing, making it so that light seems to kind of trickle everywhere inside of a room or whatever, so that it simulates it nicely. But again, extremely
slow?
Oh,
yes,
yeah.
Extremely slow.
And even radiosity is just an approximation, and yet it's still extremely, extremely slow.
Right. So let's go ahead and move on to the next guy, the OpenGL library, which is divided into 3 main categories. Basically, we've got GL, which is our core functions, if you will. We've got GLU, which is our GL utility functions. And then we've got Glut, which is quite handy, depending on what it is you need to do, especially for quick testing. It's a Windows interface, if you will, where we can go in and and create our windows. Now, let's go ahead and back up with GL.
So first with our GL, what is that? That's where the main functionality is. That's where all the core functions it is that you need to create your virtual world are inside of GL.
Exactly.
If you want to create your faces, your geometry, your lights, everything is inside of GL. GLU is a way to simplify the GL calls, to make it so that it's easier to do certain things. Like I have on the slide here, polygon tessellation, curve creation, camera management, all of that could just directly be done with GL, but GLU provides very nice interfaces into GL, so that you can have one simple call that does something.
For sure.
So like create a sphere, move your camera around, look at a certain object. It makes it much more easy. And Glut, like we were saying before, even though it's a really simple interface, it allows us to create windows like really quickly. And
very little code.
Very, very little
is required.
code.
You guys are going to see this, as a matter of fact, as we get to the end of this video.
Yep. And it's really useful. However, it's not extremely powerful, and it's not meant to be. It's meant as a very simple interface for doing tests, understanding how OpenGL works, and so on.
You're not going to want to go in and create a complex game with Glut.
No.
And you're definitely not going to want to create some sort of 3D application package.
That's right. It's just will not work.
No, not without you stressing yourself way
totally
too much.
Out, yeah. But at the same time, this is Glut is made by the same people that made OpenGL. I mean, it's the same specification, so it is tied very closely with OpenGL. So that is a big
tightly
plus.
integrated.
Yes.
Okay, so moving right along, the OpenGL commands, which divides up into 4 main sections.
Yep. Basically, we have our primitive functions, which allows us to define our geometry. So we have the GL vertex, and we can define our geometry. Attribute functions. These are very important. What if we want to, say, change the color of something?
Exactly.
We want to change the line width of the lines we draw. And it just goes on and on. We have our attribute functions. Viewing functions. Where do we want to draw everything? How big do we want the area to be? How do we want to draw it? All of that is in the viewing functions. Transformation. How do we want to move our objects around? Do we want to rotate them, scale them, transform them in any way? We have our transformation function. So it's pretty much divided into these main 4 sections.
Right, exactly. Okay, so this is a really important one to understand.
Oh, yeah.
OpenGL is basically a state machine.
Yes, it is.
Which this means what we're going to do is we're going to set things.
Right.
And those things are going to remain set until we reset them or change them to something else.
That's right.
For instance, if I wanted to create vertices with a particular color, I could set the color, the attribute color, to red.
Yep.
And then as I begin creating vertices, they're going to have the color red associated. Now, if I need to change over to blue, I need to go in there and change the state of that color to blue.
Right, switch it over.
Exactly. And then as I begin creating, of course, everything's going to be using the color blue.
Right.
So if I need to get back to red, now I need to set it back to red. But this is where we also have the ability to utilize a stack.
Right.
Which means
an attribute stack.
Yeah, an attribute stack. We can take these attributes and push them onto a stack, which is handy if you've got, a nice list of attributes that have all been set.
Like a certain function, you say, I want to set this attribute, this attribute, this attribute, and, you can't record all of those.
Exactly.
So you push the whole lot onto a stack.
Then you can change them.
You change them.
You go in and you utilize your changes. By now you're creating some more geometry that's utilizing the values of your current state of the attribute.
Right.
And then once you're done, you can go in there and pop off the attributes that you've stored to kind of switch back to what you were using a second ago and continue creating geometry.
Exactly.
It's very handy, and we're going to get into all of this later. We'll talk about GL push attrib and GL pop attrib. Yeah.
And if you just want to check certain attributes, see what it currently is, maybe the flow of your application may be different.
We've got some nice functions down here.
You can get actual values of the current attributes, which is really, really important sometimes. Sure. And finally, a very, very important concept is the rendering context.
Yes.
Each OpenGL state is stored inside of a rendering context, which can be specific to whatever viewport or window you're working with.
As a matter of fact, hang on, guys. Close your eyes. Picture the following. You've got Maya up in front of you. You've got 4 different viewports.
Right.
They're all viewing different things. You've got one set to a shaded mode, one set to a wireframe mode, etc. These are, in essence, different rendering contexts.
Right. They hold different state machines.
That's right, exactly. Otherwise, that would be extremely tricky.
Right, if each viewport was exactly the same.
Yeah, wow. Now, of course, you can have multiple viewports that share the same rendering context.
Right, if you wanted to.
Yeah.
And that can be useful in certain instances as well. So basically, the main thing you need to remember is that OpenGL, while it's going through your application, it's going to be swapping between different states constantly.
Right.
And as long as you understand that and that you know if you change something, you better change it back if you don't want it to continue, then you're all good to go.
And that is being stored in a rendering context.
That's right.
So you could have multiple rendering contexts, and at that point you really need to make sure you keep track of what's going on in each rendering context.
Exactly.
Very important. All right, so moving right along. There are 4 primary buffers. Notice the word primary.
Yep.
This does not mean that this is all the buffers that you have.
You can create
custom buffers.
Exactly.
That's right.
But the main thing you have, the main important guy that you always need to remember,
the frame buffer,
is the frame buffer. This is where you're going to, OpenGL is going to draw all the final geometry.
That's right.
Whatever you want the user to see. And it's basically just a large chunk of memory that holds pixel information about your viewport. So it could be, of course, you have different pixel formats that you could store. Let's say like RGB, which is simply red, green, and blue information for each pixel. Or it could have an alpha channel, or it could have like different bit depths. You know, like 32-bit color, 24-bit color. That's all stored inside of the frame buffer and can be set up depending on which window view interface you use. You can either set it or not set it. So it allows you to have a lot of control.
That's right. Now, back buffering is an extremely important thing to understand. Basically, back buffering is 2 frame buffers.
Right.
You've got one frame buffer that is basically the information you're viewing on your monitor.
That's right.
And then you've got another buffer, another frame buffer that's sitting in the background in memory that's going to be used to receive the next image that you're going to see on your viewport.
Yeah.
And we populate that chunk of memory and then we swap them out.
Right.
And so all we're doing is swapping back and forth, back and forth. That's it.
So while the user is looking at one thing that's saying static, we're drawing in something that people can't see. And when it's done, we just start looking at the other one.
That's right. Because if we use single buffering, now which we can do. But now what you've got is your viewport or your monitor. You're looking at that frame buffer.
While it's being drawn.
So while it's being drawn, you're watching flickering and things that are being added to it. And depending on how fast your video card is, etc., it could look really bad.
Really, really bad.
It's really a good idea to use back buffering because it just gets all the flickering out.
And that's right. And since it's so easy inside of OpenGL, it requires one extra call. So might as well utilize it.
There you go. Another very important buffer is the depth buffer.
Yep.
And this is important because think about it. If you've got a scene that's got geometry, that's behind geometry,
Yep.
Do you really want to waste processing power drawing something that's been occluded by 4 other objects in front of it?
No.
No.
and not only that, if you're drawing, say, things like translucent objects that are partially transparent, you need to know which one to draw first or last. Otherwise, you can get really weird artifacts.
You'll kill the effect.
Right. You'll kill the effect entirely.
Yeah. So
this is something that is important and we'll discuss later.
Basically, all we're doing here, though, is we're recording distances
from the camera.
For each pixel.
Right.
But for where each object is. And then we're just generating a grayscale map, basically, that contains these depths, if you will. So for any of you out there that are very familiar with depth map shadows and how the depth map is generated when dealing with depth map shadows, it's very, very similar.
Yes, it is.
And then the stencil buffer, yes. Remember how we told you guys a few minutes ago that when doing real-time graphics with OpenGL, it's a bit limiting, no shadows, no reflections. Well, like we said, there's workarounds.
Yes, there is.
And the stencil buffer, he's our friend.
He is our friend.
That's right.
It basically you can generate a mask, which is the stencil buffer, that wherever it's white or black, you can decide it will draw or not draw to that particular pixel. So, which allows us to generate a mask.
That's right.
So we can draw here, don't draw here, etc. It can be very, very powerful.
Now, are we going to get into... I know we're going to get into stencil buffers pretty heavily in the intermediate techniques.
Right, we are.
We're going to talk about it a little bit here. I can't remember.
No.
I didn't think so.
No.
Yeah, it's just letting you guys know these are the primary buffers, if you will.
Right.
But that's why I wanted to bring that up.
Yeah.
I think we're going to pretty much stay away from stencil buffers in the introduction to OpenGL VTM. But in the intermediate VTM, we're going to put these to good use as we show you guys how to do reflections, shadows, all that good stuff. Woohoo. All right, this is really cool.
Interfaces.
So...
how does this work?
How does it work? Yeah, the whole thing. We've been talking about a lot of different things so far. Well, it obviously needs to begin with an application that you, the programmer, writes.
Right.
And this application, of course, is going to utilize OpenGL because we're creating an application that's supposed to do graphics utilizing that library.
Yes.
So it's going to basically, inside your application, you're going to make calls to the GL utilities and to the GL library itself.
Right.
And you'll notice that GL utilities makes use of the GL libraries. Again, as we said earlier, it just simplifies that whole process, which is really nice. So we'll make calls in both directions. Now that's us communicating with the OpenGL library for creating objects, doing transformations, projections, lighting, etc. But that is not going to give us a final application on the screen that a viewer sees. We obviously need a window. We're going to need controls, buttons, things for the user to interact with. And so at this point, we really need to pick some sort of Windows interface that we're going to use. In C++ VTM4, we introduced you guys to WX widgets. As a matter of fact, in that VTM, I believe Joel took about 10 seconds and pointed out where we can tell it to use OpenGL.
Right, when we're compiling it.
That's right. Now, of course, we're going to get into that heavy in this VTM.
Much more.
But in that VTM, we just mentioned it lightly. But there are more interfaces than just WX widgets out there. We've got Glut, we've got Windows API, and we've got SDL.
SDL, each has their own benefits and disadvantages.
And drawbacks, that's right.
So things like SDL, it's meant for games, that's what it was designed for, and it's
Glut,
really good at it.
Meant for quick tests, if you will.
Quick tests, in the academic world, it's used a lot.
WX widgets, if you want to crereate a full-blown 3D type application, WX widgets is a great way to go. The Windows API, also pretty good, but things like WX widgets give you access to a lot. It simplifies.
It simplifies
a lot.
A lot of people totally hate the way the Windows API does things, and that's totally understandable. But if you want something that's really fast, really closely knit with Windows API is an awesome way to go.
So here's the cool thing about this VTM. We're going to walk through all of these. We're going to show you how to get the libraries set up properly so that it'll compile right, of course, in .NET, and then we're going to walk through creating applications. As a matter of fact, the same application with each one of these different window interfaces so that you guys get a really solid feel of the differences between each one, which is
cool. And that's important.
And then, of course, as we specified a second ago, what you're going to see on your monitor, well, gets, rendered through the frame buffer.
Exactly.
So,
and
of course,
on your screen.
There we go. All of this stuff comes out to the frame buffer, then out to your screen. You'll notice how our applications making direct calls, connections, ties, however you want to look at that, into these Windows interfaces, and also at the same time, these window interfaces support OpenGL as well. And then,
so it's talking to OpenGL as well.
Exactly. So there's a lot of back and forth going on here. So this is a really nice big picture, if you will. Moving on ahead, primitives.
You need to, at some point, create stuff inside of your virtual world.
Well,
start populating it with stuff.
If you didn't, it wouldn't be much there.
No, it wouldn't be much of a world. It'd be kind of blank.
Now, what's really interesting here is you guys are all familiar with C++. You know how you use the curly braces for defining a block.
Right.
Well, when communicating with OpenGL, we use GL begin and GL end to specify a block.
A block of geometry that we're going to create.
We're about to create a vertex, or there's a bunch of different things, and we're going to show you those in a minute. But we define these things inside of GL begin and end.
Right. So basically, if we want to, let me go over to here.
Okay.
Get the mouse. So basically, when we have GL begin, we define inside of this parentheses
what it is we're about
what kind of thing we're about to create. Like, let's say GL triangle. Do we want to create GL points, GL lines, etc.? And then inside of this block, before the end, we define any vertices that we want to create for that. So let's say if we say GL begin, GL points, and then every GL vertex after that is going to create a point.
As a matter of fact, just to help make it a little bit more clear, since we've already brought up attributes and the state machine functionality of OpenGL, it's also good to point this out here. We say GL begin, we can go in there and then set a color, GL color, and say here's what our RGB value is going to be. So we've just set an attribute. Now create the vertex. Now let's change the color again. So all of this type of information is taking place inside the GL begin.
That's right, and throwing it into different states and so on.
Exactly.
Now the star may be a little bit confusing to you. Well, all this is really doing is specifying what kind of vertex or attribute we're creating.
That's right.
The command suffix, if you will.
Yep.
Which allows us to say, let's say if we're in a 2D world that's entirely 2D, we can say GL vertex 2D.
That's right. Well, it could be 2F as well.
2F,
but the 2 is a really important thing because at this point we know we're looking for 2 points.
That's right.
Now the F or the D, well, how are these points going to be specified? Are we looking at a float value, or do we need a double for a higher precision?
Right.
Etc.
Or are we just working with pixels and just using integers or something like that? It depends entirely on what you're wanting to do.
And in a second, we're going to talk about all these command suffixes, and we've got them all laid out for you, which is quite nice. But yeah, it's really important, as you can see down here.
It's not just used in creating vertices.
No.
It's used in creating colors and
Absolutely.
all sorts of different things.
Absolutely. Well, here's a good example right here, GL Color 4. And so in this case, we're dealing with an alpha as well.
Right. Otherwise,
really nice.
If you just say GL Color 3F, then we're defining a color with R, G, and B that's ranging between 0 and 1 for each channel.
That's right. So don't let all of the numbers and letters at the end scare you because they're changing with the use of the same command. It's really just specifying, okay, here's what we want you to create.
Right.
It's going to be a vertex, but this vertex, does it exist on a plane or does it exist in 3D space?
Right. OpenGL is a really large library and it has to target a lot of audiences.
Don't scare them. It's not that large.
So people need to have various ways in which to utilize OpenGL. That's right. And some people have 2D, some people use 3D, and so on. So it needed to apply to all audiences.
Once you wrap your head around just a few very simple things, we're starting to get into the heart of those things right now. You're going to find OpenGL to be a very friendly library to work with. Very friendly.
And especially with the GL utility libraries, it makes it even more friendly, which is very cool.
So here we are, commands, suffixes, and it's hard to say, and corresponding argument types.
Right. So basically what we have here, as we said before, we have the letter, which a second ago we said F, which is a floating point, 32-bit floating point number, which for those of you that do not know is like 3.22 something or etc. And then we have D for extra precision. If we wanted to use an integer, we have I, a short, Boolean, and some of these, like a GeoVertex, may not have all of these suffixes, but some of them do, some of them don't. So if you have any confusion, well, what's that mean? Just look to the list.
Now, please correct me if I'm wrong here.
Okay.
But inside OpenGL, everything's converted over to doubles.
Right.
Okay, good. So people...
when you're creating a vertex, it's always created at the end.
At the end as a double. So you'll hear some people out there, or you'll see some books that are going to just refer to as just use double.
Right. Some people, like my teachers, will say that you always should just use doubles anyway for extra precision. However, I typically like to think that if you're using an integer, let's say you're just dealing with vertices, and an integer works fine for you, use an integer because it makes more sense for your own data types. Don't try to always use a double just because it seems to be the right thing to do.
Absolutely. And with that brings up something really cool. You just talked about data types.
Yes, data types.
Ooh, this is an area where you need to be really careful if you've got cross-platform in mind.
Right, because depending on what compiler you use, GCC, Microsoft's compiler, Intel's compiler, whatever, they may be... defining their data types in a different manner. Say you're using an integer on one compiler, it could be defined as 16-bit, or it could be defined as 32-bit.
And this could cause extreme grief.
Yes, it could.
If you go from one compiler over to another one.
Right, when you're dealing with things like OpenGL, which is supposed to work with every compiler.
That's right.
And then there start being different data types and things go haywire.
So fortunately for us, OpenGL takes this into account. And what they ask you to do is use the equivalent OpenGL type as opposed to just going in there and specifying an integer or a long or a double.
Right, and it's just a type def that makes it so that no matter what platform you're on, it guarantees that you're using the same size. And that's very, very important.
That is very important. Okay, well, we talked about the GL begin and end, and GL begin takes in, what is it that you're about to create? Well, here's the list of things that we can create. GL points, lines, line strips, line loop, triangles, triangle strip, triangle fan, quads, quad strip, and polygon. And this is all really simple. I mean, basically it breaks down into we're just going to create points. Right. We're going to create lines, which requires, just 2 points. Okay, so now if we give it 2 more points, we're making another line. Right, and then we have 3 ways to create lines, which is really cool, depending on what kind of thing you want to create. Right, because if we wanted a line that just had segment, and then another line segment, and then another line segment, we'd use something like GL line strip. Right, which for every new vertex you create, it creates another line. That's right. If we needed to have something that at the end closed back to the beginning, then we'd use a GL line loop. Right. So you could specify 2, 3, 4, 5, whatever, points, and then after that last one, it's going to basically draw a line connecting back to the first point specified. Now, of course, we need to get into the world of faces. So in working with GL triangles, just the GL triangle itself is going to give you just that, a 3-point triangle, boom, there's your face, yay. Now, if you need to specify multiple triangles, like in this case here, we've got 1, 2, 3, 4, we've got a GL triangle strip. And in this case here, you'll notice that V0, V1, V2 define this triangle. Now, 2 of these points are shared in the next triangle. So 1 more point is all that's required to come up with the second triangle. And some people may be going, well, why would you want to have multiple ways to create a triangle? Well,
depending on which one you use, it could be more optimized. I mean, think about it. For the first one with GL triangles, you have to define 3 vertices to create one triangle. With the second, you define 3 vertices for one triangle, and then for every new vertex you create, it creates another triangle.
That's right.
So obviously that's much more optimized and faster because you have to define less vertices.
And then moving on over, we've got GL triangle fan, which is anytime you need to create a series of triangles that share a point, like you were going to create
a cone, maybe.
A cone, yeah, that's a good one. Then this is, or let's say a cylinder cap where you have a point in the center. In this particular case, all of these triangles right here, I'm hunting for my mouse, there it is, all these triangles are sharing this same point.
Right.
And then, of course, we move down to the wonderful world of quads and the polygon itself.
Yes.
Same thing that's going on down here. GL quads, 4 points, there's our quad.
Yep.
4 more points, it's a whole new quad. Again, if we need a strip of quads, same type thing, allowing us to optimize the creation of multiple faces.
Right.
And then, of course, we have the GL polygon.
Right, which allows you to define n number of vertices.
An infinite number of vertices to generate a face, but
yes,
you need to be careful.
Yes, because you cannot have them non-planar.
That's right.
Because it's not really defined in the specifications what's going to happen when you have a non-planar face. Therefore, try to keep it planar.
That's right.
Yeah, otherwise you might not know what's going to happen. And also, people typically like to use triangles over quads simply because of that very, very reason. I mean, if you have a non-planar quad, you may not know what's going to happen with it as well.
Right.
So, as you see in most game engines, they ask you to first convert everything into triangles before exporting it out. And that's the reason, just to make sure that everything is defined and the behavior that you get when you export your geometry into your own application is, defined, and you know exactly what's going to happen.
All right, moving on. Here we go. This is important. Typical application flow.
That's right. How exactly does an OpenGL application work and run? So basically, we start out with creating our window, because we obviously have to have some place to put our stuff, right?
That's right. And you got a little asterisk here, which just really denotes that, whatever window interface you use, it could be SDL, it could be Glut, it could be WX widgets.
Yeah, it just depends entirely on which one you're using. But it basically accomplishes the same thing. It creates a window.
Ta-da!
So then, after we've created our window, we need to initialize OpenGL. And initializing OpenGL can be as simple as just saying, set our clear color, so that when we clear our frame buffer, what color it is.
Right.
Or it could get more complex by saying, what do we want to have textures? Do we want to have line smoothing? What's our point size? And there are tons and tons of attributes that we mentioned before. We want to set up our initial state.
Oh, good man. You said it right. Because that's exactly what's going on.
That is exactly what's going on. You're initializing your OpenGL state. So that you can set it up for every single function, but setting states, changing the state of OpenGL does take processing time. So if you know that it's going to be in a certain state, get everything set up right at the beginning so that when you get into your loop, everything just utilizes whatever state it's in.
That's right. You really wouldn't want to redefine the state over and over and over in the loop.
Again. Yeah, that just makes it slow.
Yeah, that would be.
So then we have our start of our main loop, which starts, depending on what window interface you're using, it will throw it into an event catching loop. So whatever events happens, it knows to catch those or not catch those and all that stuff. So then it gets into basically our drawing code, our drawing function, if you will. So this is where OpenGL comes into play and starts doing its thing.
And this is where it's very little code usually.
Yeah, hopefully, if you're defining your stuff right, this part of the code should be really small, because you want your drawing code to be fairly compact. You want it to do very simple things, draw a triangle, do very, very simple things. So the first thing we need to do in our drawing code is to clear the frame buffer. Remember, if we're using a back buffer, it already may have something on it. So we want to clear.
In this case, if we're using double buffering, it is the back buffer that gets
we're
cleared.
not seeing it.
That's right.
So we don't see flickering or anything.
Of course, if it's single buffering.
If it's single buffering, then if you have a slower computer, you'll see it actually clear it.
Wipe it.
And then as you draw stuff, it will slowly draw stuff.
Right.
That's not good.
So after clearing?
So after you clear it, you need to reset the model view matrix. Right. What this is really saying is that we're resetting our transformation. Say we moved an object to 500 or something. We want to set everything back to 0 to start a fresh slate.
Right.
So we reset the model view matrix. And at this point, we can start drawing our objects. Move our object. I want to draw a cube. I want it to move it to 730. Put that here. Move it again. Put it to here, and so on. And that's where the drawing occurs. And at the very end, once you've got all your geometry defined, everything is where you want it, your virtual world is set, you need to flush the graphics buffer. And what this is saying is, I've defined everything, sent everything to the OpenGL server, if you will.
All right, well, just in case anybody gets confused there, basically
confusion.
you can visualize the entire OpenGL process, if you don't mind me saying it that way, as a client-server type relationship, where from the client we're telling the server, set the state, set this, set that, we're going to make this, we're going to do that. And then what we need to do is tell it to do a GL flush once we're ready for rendering to take place.
Right.
And then
it sends that back to the client.
And then it gets sent back to the client, and now we're ready to proceed.
Yeah. So once you do the flush, after you do the flush, it's going to be in the frame buffer. Either it be the back buffer if you're using double buffering, or it's going to be...
Or you just saw it on your viewport or your monitor if you're using single buffering. And, of course, if you're using back buffers, at this point, you are responsible for making sure that you swap the buffer.
Right.
And there's an asterisk there just denoting the fact that, there's different ways to go about it depending on which Windows interface you're using.
If you're using, like, Glut, you have a Glut swap buffers. If you're using Windows, it swap buffers and all this sort of thing.
Exactly. But we're going to talk about...
But it's just one line, so it's not too complex.
Now, let's see if we could take everything we've talked about and show it in action. Ba-doom. Wah, 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 wah. All right, so let's go ahead and run our little program right here.
No, it's not. No.
It's not going to run?
No, it's not going to run. It's all good.
Oh, we're not attached to it. Anyways, okay, well, I thought we were still attached. Oh, must have got closed out.
Yeah.
That's okay. Let's go ahead and just talk about it.
Right. We basically have our int main, which is our main function, which is right down here. And this is where everything begins. Like, if you know C++, you know how this is working. So we start out here. Let me just...
See?
Yeah.
Haha, see?
It just took a second.
Yeah. So here's the application running for real.
And as you can see, all it draws is this really, really complex triangle. Very, very complex.
Very complex.
And all it's really doing is, like we said before, we have a GL begin, GL end that defines our triangle with 3 vertices. And each vertex has a different color.
That's right.
And what's really cool about the way OpenGL is doing this is it blends really nicely between each of them. And what's really cool is this code... are you done with this?
I was just going to show them that there is a real program.
And it is. So if we... Oh, and actually, you can... I'm sorry. Once we have this here, all we have is this little bit of code, which is, 30 lines of code or so.
It's very small.
And it creates that entire window with everything already managed for us.
The interesting thing to point out, let's go ahead and start up here with our include.
Yeah.
Notice how we're including just the Glut header.
Right.
We don't see anything that's talking about GL or GLU or whatever. That's because the Glut header takes care of including those things. That's right.
And that just makes it more simple for us.
Then from there, let's go ahead and jump down here to our main function.
Right, and the first thing we need to do is initialize our Glut, because that's the window interface that we're using. It has some things internally that it needs to set up. So simply call Glut init and initialize whatever we need. Then we're going to set the display mode to use double buffering. And see, this is the cool thing. I mean, we could use single buffering, but that causes flickering, or we could use double buffering by changing
involves one extra line of code.
Right, that's right. I mean, so might as well use double buffering.
Yeah.
So we initialize...
Well, you change that, and you also need to make sure you're handling the swap. That's right.
But that's just one line.
I know.
Yeah, so we initialize the display mode, and then we create our window. This is the cool thing. One line
makes that window.
Yep.
Notice how over here the argument we're passing to it, OpenGL test. Take a look at that.
Yep, OpenGL test.
There's your title.
I mean, it's so simple to do.
It's really simple.
And then we need to set our display function. Now,
this is important.
This is very important. Inside of Glut, everything is going to be based on callbacks. So let's say I get an event that the mouse has moved. It needs to know, should I handle that event? Who should I call to handle that event? In this case, we want to handle the drawing. So when the window gets overlapped with another window and it needs to be redrawn, who should I call to handle that?
Precisely.
And with Glut, you always need to define someone that's going to handle the drawing. Because if your program doesn't handle the drawing, what's your program doing? Because Glut is designed to work with OpenGL, so it needs some sort of drawing function.
That's right. So here we are basically establishing which function we're going to be calling.
Right, and we just passed the name of our function, which is displayCB, and that calls this guy right here.
That's right.
So every time there's a draw, this function is going to get called. And if we just go back for a second,
go ahead.
This is creating our window. So we've got that done. Everything we need to do is 5 lines of code.
That's right. So now it's time to initialize OpenGL.
Right.
Which, as you said, could be as simple as just setting our clear color.
Right. So we call it GL clear color, and we pass it 1, 1, 1, which means that we're passing it full intensity for R, G, and B, which that means it's going to be white.
That's right.
If it was 0, 0, 0, that's black. So we simply pass it that, and we've initialized OpenGL for our set. We've set it into the state that we want. And then all we need to do is call glut main loop, which sends it into that main loop. If we just go back into our diagram here, start of main loop. This starts the whole event passing thing, and then anytime it gets a call, a graphics display redraw thing, that calls our function so that we can start everything going on here.
That's right.
And for our simple application, that's all we need is that one display callback. So if we go back into here, and also, once it gets called into glut main loop, it's never going to return. It now handles exiting your application and everything. So even though it never gets here, it's always good practice to put a return 0
Sure.
there. Anyway, because of course we have an int right here, so it's kind of important. So when this display callback gets called, remember, the first thing we said we need to do is clear the frame buffer so we can start afresh. And that's going to be simply done with a GL clear. And you pass it what you want to clear. In this case, GL color buffer bit. If you need to clear the depth buffer, if we were using a depth buffer, this is a 3D world and we're handling that, you would also pass it the GL depth buffer. And then it would clear that at the same time with a simple or whatever attributes you want to, whatever buffers you want to erase. And then we need to clear our model view matrix, so we simply call GL matrix mode GL model view, which is simply saying which matrix do we now want to modify, and GL load identity will clear out or reset whatever matrix that we're currently modifying. So it clears that out. So if we look back here, we have just cleared the frame buffer, we've reset the model view matrix, now we need to draw the objects.
Which means we're going to be looking for a GL begin, GL end block.
And as you can see here, we have our GL begin, GL triangle, since we're just drawing one triangle. And then notice how we were talking about this before. We need to set the color, create the vertex, whatever it may be, and then set the color again, create another vertex.
Because we're dealing with that single attribute in this rendering context. That's really important.
Yes, it is.
Because if we don't go in there and change that color after each vertex, then you're going to end up with just red, red, red. It's just going to be a red triangle.
Exactly. So if you look at this, we have GL vertex 2F. This is something also that's very important. Notice it's 2F, because that's a 2D image that we have
right.
here.
That's right. So, and we talked about that earlier. And then, so 2, specifying that we're going to be sending 2 points here for this vertex, so on a 2D plane. And then what kind of data? It's going to be float values, and we're sending it 0 and 1. And
finally, let's just finish this off. We have a GLN, which says we are done shooting vertices off. Go ahead and draw the thing, and draw the triangle. And then we have our GL flush, which, as we said, flushes it off, sends it into the frame buffer.
Needs to get it rendered, basically.
Go get it rendered, exactly.
That's right. And then at that point, it's rendered and it's sitting on your back buffer since we're using double buffering, so we still don't see it on our monitor. So, of course, in the end, we're responsible for making sure that we swap the buffers, which, that's real difficult.
Oh, yeah.
One line of code.
Ooh, very difficult.
So let's go ahead and bring this up. We'll talk about the numbers that we're using with GL Vertex as we send it in 0, 0, and 1, 0. So basically, the way that this is laid out right here, going from the bottom left-hand corner, -1, -1, to the upper right-hand corner, 1, 1.
Right, it basically defaults to having the center of the screen to be 0, 0.
Exactly.
And we'll be exploring this more later, how we set up our virtual viewport so that we can have whatever coordinates we want. Let's say we wanted it to go from 0 to 500, 500 or something. We can set that.
Right.
But by default, it is set to 0 is in the center, top right is 1, 1, bottom left is -1, -1.
Right, and of course, if you just follow this around, our very first vertex is going to be at 0, 1.
Which is x, y.
That's right, and then, of course, it's going to be 1, -1. You can see how this is just working its way around, creating the vertices.
Right, in a clockwise fashion. And that's something else that it's kind of important to bring up. We'll talk about this more later when we start dealing with 3D worlds, but how you define your geometry is also
-1, -1. Oh, sorry.
How you create your geometry is very important. In this case, we're creating in a clockwise fashion.
It's very important, actually.
Very, very important. When you start defining 3D geometry, you have normals, which direction it's pointing. So how you define your geometry becomes crucial. And I think that's the main thing that can trip people up sometimes when they start working with things like OpenGL, is all these subtleties. There's a lot of things you need to remember, but once you know those things, creating your own virtual worlds becomes very, very simple. That's the cool thing about things like OpenGL or DirectX.
Right. Now, guys, don't panic. There's a lot of things that we're going to be talking about in this VTM. And by the time we get to the end of it, if you come back and rewatch the introduction, everything's going to make complete sense.
Make complete sense and seem really, really simple.
Well, by the time we're done, It will be very, very simple.
It will be very simple.
Working with OpenGL is really easy. And as we progress into the second VTM, after you guys have created your own particle engine and you've really gotten in there and seen how all this stuff interacts together to give you a graphical image on your monitor, then we're going to push things even further.
Oh, yeah.
So you guys are going to be graphic application programming devils.
Yep.
Yeah. So anyways, with that, that's going to wrap up the introduction, and let's go ahead and get started with the rest of the VTM.